I'm going to record.
All right, so we are going to start off this course with basic counting. This is going to be a fun topic. Ishani, do you want to go over like what math counts is, stuff like that?
Yeah. Okay, so essentially math counts is a competition that's usually for middle schoolers, so up until 8th graders. So you have two sets of two tests that everyone takes, the sprint and the target. And then you have and if you don't take, and if you're part of the team for your school, you will take the team test. So there are those three. So essentially, the target has 8 questions, and in sets of 2, you're given a few minutes for those, and you're given a calculator. But for the sprint, there are 30 questions, and essentially you try to complete them within like 30 minutes, I believe. And it's like you have to, or 45 minutes, and you have to do it like quickly and without a calculator. So you all are in 8th grade, so most of you probably have experience with math counts, and if you aren't, then, or if you don't, then hopefully you'll be able to do it this year. So yeah.
Yep. And then also this course, we will try to make it fun. Even though it's math, like we swear it will have some fun stuff. So yeah. All right, let's get started. So I'm sure all of you guys know how to count, or at least I hope you do. Don't tell us if you don't. And it's a skill that like we all use a lot of the times. So just to start off, how many classes are you guys taking? Because that involves counting. Like I have 4 classes on red days at my school, 4 classes on white days, so 8 total classes. 12 classes? Okay, well, I know William's not being serious with 74.2. Are you being serious with 12? Okay, extra ones. I see. So it seems like you guys can count. Good job, congratulations. You can count it if you want to, I guess. How many siblings do you have? This is easy. I have 1 sibling. Wow, 100 siblings. That must be a really big family. I feel that. Same, honestly. Except my brother is actually like really smart, but he's just super annoying about it. All right, let's continue onward. So sometimes like in math problems, counting can actually get hard because there's either like a lot of things to count or it's just easy to miscount certain things. So like if you had to count how many strands of hair were on your head, ... You could like do it from 1 to 2 to 3 to like 4 million to 500 million, something like that. But you really don't want to. So so we're going to kind of apply a method of thinking. Instead of just like brute forcing hard problems, you need to think about strategies you can use to make the problems easy. And this is a wise quote by a smart math lover, aka Kayang.
Okay, so count the number of numbers. So 1, 2, 3, 4, 5. I'm seeing a lot of people saying 5 numbers, and good job, you are correct. So there are 5 numbers. So 1 until 24. Yes, a lot of you are getting it right. It is 24 numbers. There are 24 numbers. So yeah. So notice, yeah, okay. So now 4 to 10. How many numbers are there? Okay, yes, it's 7 for everyone who said 7. So if we just count the numbers, we can tell. So how many numbers are there between 5 and 90? So this would be harder. And obviously it would take a little bit of time to count like all of the numbers from 5 to 90. So as we said earlier, we want to find a shortcut. So I'm seeing a lot of you putting 86, and that is correct. So you notice how like when we're counting from 1 to 24, the first number is 1, and it's also the first number, and like the nth number is n, right? So like the 10th number is 10, right? So and so on and so forth. So now we want to like shift this so it's essentially like so that the 5 is equal to a 1, right? So that we have 5 to 90, but we can shift it down so it's a series starting from 1, and we can count upwards. So we would subtract 4, and we would get 1 until 86. And essentially, that would show that we have 86 numbers. So if you subtracted 90, if you did 90 minus 4, you get 90 minus 5, you get the answer of 85, because you would incorrectly assume that that we're starting from 0 instead of 1. So however, if we do this, we're leaving out one of the numbers. So considering 1 through 5, we know that if there are 5 numbers, but 5 minus 1 is only 4. So we would want to subtract 1 less than the number away from than the first number. So we can get 1 as the first number. Okay, so
right.
Yeah.
Okay, thank you. Okay, so let's take it up a notch. And now we're going to count with patterns. So how many numbers are in the first box? Yep, 4, that's easy. Don't do 20 minus 5. That would be like 15 numbers, which is absolutely not right. Okay, how many are in this pattern? Yeah, it's not that fun when it's hard, is it? All right, so we are all saying 12, and that's correct. So the strategy you can use here is like, we're going to reduce it down to that basic like 1, 2, 3, 4, 5, 6 sequence. And you can do that by dividing every number in that pattern by 3. That gets you the numbers from 1 to 12, and which we already established is 12 numbers. Okay, what about this one? So this one is where it starts to get tricky. But what you can do is you can think about applying the strategy I just mentioned in the previous one. So first, what we can notice here is that like you're adding 4 each time in the sequence, and then it starts at 7. So first we can subtract 7 from all of it, and then we can divide it. So if we subtract 7 from all of it, we get like 1, 4, 8, 12, blah, blah, blah. And then if you divide all of that down, then you get back to the original sequence, which is just like 1, 2, 3, 4, all the way up until 22. So you guys are correct. There's a slight inaccuracy in the explanation there, so. Shauna, you're muted.
Sorry about that. Okay, so the fundamental counting principle. So okay, next slide. So if there are p ways to do one thing and there are q ways to do another, and if both of them are like independent of each other, then there are p times q ways to do both things. So if I have 8 shirts and 4 pair of pants, how many unique outfits can I make? So we do 8 times 4 in this scenario, and we would get 32, as many of you are saying. However, if it were like, if I have like 2 if I have 20 socks, how many ways can I choose, like 1 green, 1 red, like or 1 green and then a second green, right? That would those aren't independent events, because independent events means that the first or event doesn't impact the next, right? So make sure it's independent event. Okay, so second example. If I have 6 sweaters and 3 skirts and 4 necklaces, how many outfits can I make? So yeah, a lot of you said 72. 6 times 3 is 18. 18 times 4 is 72. So there are 72 outfits you can make. Okay, so now a few fun problems. Okay, how many numbers are in the list? 3 and 2/3, 4 and 1/3, 5, 5 and 2/3, and so on until 27. So yeah, this is a bit more complex, but remember what you did last time. You, for the one that was 7 to 91 and went up by, I believe 4, like but that went up by 4, you like shifted it down until it was like, until the first number was a 4, which was the first multiple of the common difference. And then you divided it by that common difference, right? Okay, so I am seeing a lot of different answers, so I'll give you an extra minute and then, yeah. Okay, there are a lot of different answers. So I've seen 50, okay, I think all of these are for this problem. 41, 54, 57, 27, 36, and 32, and 31, and 27. So that is very different, right? So first we see what the common difference is. So what do you have to add to 3 and 2/3 to get 4 and 1/3 in the chat? Okay, right, you have to add 2/3. So we want to subtract a value from 3 and 2/3 so we can get this, the first multiple of 2/3. So 2/3 times 1 as the first number. So that's easy. We just want to subtract what number from 3 and 2/3 to get 2/3. Okay, yeah, good job, Aryan. It's 3. So in order to get 2/3 from 3 and 2/3, we'd subtract 3. So yeah, so we get 2/3 all, and then we're adding 2/3 each time, and then all the way until 24, right? Now we want to get this first number to be 1 by multiplying or dividing, right? And also there is not homework. So in order to get our first number to be 1, what do we multiply it by? So in order to get 1 from 2/3, what do we multiply 2/3 by? Right, 3/2. So we also want to multiply all the numbers between 2/3 and 24 up till 24 by 3/2. So what's 3/2 multiplied by 24? Right, it's equal to 36. So that means there are 36 numbers in the list. So I think I saw 1 or 2 answers that said that in the chat at the beginning. So good job. But for everyone else who did not get it, by the formula, well, wait, I'm gonna just finish my thought. For everyone else who didn't get it, just like make sure you understand what I just did. So Sanvi, by formula, do you mean like what I just did, or
like there's like a number of terms formula? It was like a add n parentheses and like n minus 1 times the common difference.
I think you're thinking about the sum formula.
I don't know. Maybe. I don't know. I think there is a formula, but I'm not sure.
Yeah, there probably is, but essentially when you simplify it, it would be this. So you'd want to like shift it down. N times n plus 1 over 2 is the sum, not the actual terms or number of terms, right? So essentially to find the number of terms, you want to find the common difference and then subtract a number from that first number to get the common difference, right? So if the common difference is 2/3, you'd want to get the first number to be 2/3, and then you divide everything by the common difference, and then that, or multiply it by the reciprocal of the common difference, and you would get the number of numbers in the set.
I searched it up and it says the number of terms and in the arithmetic sequence are like the last term minus first term over common difference at 1.
Okay, wait. Yeah, that would work.
Yeah.
Yeah, it would. Right.
Okay.
But yeah.
Okay.
Okay.
Right.
Okay. So next problem.
Okay. So Sandra Bullock's birthday is July 26th, and her friend Keanu Reeves' birthday is September 2nd. Every year, the two celebrate by eating cake every day from between their two birthdays, and also including the day of their birthday. So if they did this for the first time in 2008, how many cake eating days will they have observed at the end of 2016? So hopefully you guys know how many days are in each month. Like you can do the thing, counting on your knuckles. You got this. How are they alive? I don't know. Maybe they have, maybe they like just deal with the food poisoning or something from all that sugar. Is it 8 years? All right, so seeing some different numbers here. Very nice. Can't believe you're prioritizing AOPS over us, but okay. All right, so it looks like we're kind of centering around the 300s area. So all of you guys are like, I think on the right track. But like we mentioned before, it's really easy to make off by 1 errors, which can kind of like make bigger differences when you have to multiply, like in this problem. All right, so let's start solving this. So we go from 2008 to 2016. How many years is that? Put that in the chat. Yes, that's 9 years. So be careful that you don't think it's 8, but that is 9 years there. And then we have to figure out how many days they're eating all of this cake. So from July 26th to let's calculate the days in July first. From July 26th to July 31st, that would be 6 days. Be careful, not 5, 6 days. And then in August, we have 31 days. They're eating cake for the entire month. Wow, that's got to be an expensive habit too. And then
What if they're like, what if
Yeah,
they're
go
in like
ahead.
super mini cakes?
Yeah, okay, and then September, just 2 days in September. Okay, and then if we add all of that up, that's a total of 39 days per year that they're eating cake. And since they're doing it for 9 years, then you get 351. So nice job. And yeah, leap year can definitely be a challenge for problems that involve like February, which luckily this problem doesn't. All right, are there any questions about this? We love questions. Feel free to ask questions or make comments, anything. What is a question? That's a great question. All right, so let's move on to the next problem.
Okay, so Joe wants to find all the 4-letter words that begin and end with the same letter. How many combinations of letters satisfy this property? So remember, there are 26 letters, right? So yeah. Okay, so I am seeing a lot of the same answer. So 17,576. So and yeah, these aren't going to be like real words for most of them, right? So if the first and last letters want to be the same, so how many ways can we select the first letter?
26. They can be any 26 letters. Right?
Yes, good job. So it would be 26 letters because we have no restrictions on the letters we can use, and we can use all of them, right? However, the last letter would have to be 1 because there's only one option for the last letter because we've already selected that first letter, and the first and last letters have to be the same. So there's only 1. So how many ways can we select the second letter?
26.
Good job. So yes, there are 26 ways. Since again, we don't have restrictions. And how many ways can we select the third letter?
26.
Right, good job. So what we want to do is multiply these together because remember when we said earlier that if we have like independent events, we can just multiply them together to get how many total ways there are to get like a combination of certain events, right? So these are independent of each other. So we just have to do 26 times 26 times 26 times 1, right? And you could have plugged this into your calculator. I know I didn't specify if you could have, but you could have. Or you could have just done the math and you would have gotten 17,576 as your answer. So good job to everyone who got that. Yeah, does anyone have any questions? Okay, if not,
Okay, problem number 4. A state requires that all boat licenses first consist of the letter A or M in like the first spot, followed by any 5 digits. So how many possible like different licenses can there be on these boats? So somewhat similar to the previous one. We're just multiplying a bunch of things together using the fundamental counting theorem. Yeah, theorem. All right, so it seems like we're all getting the same thing. which is 200,000, and that is indeed correct. So let's start off with that first digit. It just says in the problem it can be either A or M, so that's two options right there. And now after that, for the other 5 spots, you can have like any of the numbers between 0 to 9. So how many possibilities is that for the digits?
10.
Yes, good job. So that is 10, 10, 10, 10, and 10. And then you multiply everything together because these are all independent. Like whether or not you have an A or M here doesn't affect what digits you can put in the second spot. So they're all independent and you can just multiply them together to get 200,000. It's really fun to erase everything.
Okay, so we do have a Kahoot. So, and for this, you can use your computer, or if that is slow, you could use your phone. So we can give you a minute to just get a device if you need to do that.
I'm kind of scared for the day that Kahoot goes the way of Quizlet, where they're like, on a free account, you can only play 5 Kahoots before you have to buy the pro package or
Right.
whatever it is.
Yeah. I tried to use Quizlet recently and I was surprised. So
It's really stupid. I wonder if they're killing their business.
mhm.
Okay.
Okay. Yeah, you can. Yeah.
So you can see the game pin up top and go ahead and join.
Is it made so that we can see it on our screen or?
Wait, Yolanda, go to settings on the left and make sure that it will show the questions like underneath the volume on the left. And then scroll down.
Ooh,
Yeah,
okay.
or yeah, no, never mind. That was right, what you just did.
Why did they make settings like that? Everyone always makes settings a little gear.
Right.
It's very unstandardized.
Mhm.
All right, hurry and join. You have one more, or like, let's say 10 more seconds. 10, 9, 8, 7, 6. Oh my God, a gambling website. Oh, that's terrible. I mean, I've been to worse websites for misspelling things. Okay, I think it's been 10 seconds, probably more like 15. So we're going to start. And you should still be able to join. Okay, how many numbers are in the list? 3, 10, 17, all the way to 59. All right.
Okay.
Yeah. The
Yeah.
answer was 9.
Yeah. Are we explaining the problems?
Um,
Because we do
missed
have,
that one by accident. You can explain.
I do not remember the problem.
I mean, like not this problem, but like in the future.
Okay,
Sorry, I
okay.
accidentally skipped it.
Okay.
This isn't an arithmetic. This isn't an arithmetic sequence.
Right, it
What's the
isn't.
pattern here?
But yeah,
I wonder.
It's
you can go.
Oh, okay. So if you notice here, it's like a sequence of perfect squares. So you have like 1 squared, 2 squared, 3 squared, and we all know that 81 is 9 squared. So there would be 9 numbers in this like pattern.
Okay, so essentially we can see that the common difference is 2 in this scenario, right? Because to get from -5 to -3, we would just add 2. So we want to get our first number to be the first multiple of 2, which is just 2. So what do we add to -5 to get 2? You can just say it in the chat.
7.
Or yeah, okay, yeah, good job for unmuting. So we'd want to add 7 to this, right? So we'd get our first number as 2, and we'd get our last number as 11 plus 7, which is just 18, right? And now we know that the numbers increase by 2. So we would divide everything by 2, and we would get 1 until 9, and that means that there are 9 numbers, and therefore it's red.
Are all the answers just going to be 9?
I don't know, but I don't think so.
Okay. All right, a theater group has 8 girls and 5 boys. If the 2 lead roles, 1 girl and 1 boy, are being chosen, how many possibilities are there?
Okay, so the answer is wrong, but it should be 20, or yeah, no, it's not wrong. It is 40, right? Because we have 8 ways to get a girl and 5 ways to get a boy. So we would do 8 times 5, which is 40. And that is our answer. So good job to everyone who got it. For the person who divided by 2, we aren't actually like factoring in order in this scenario. So yeah. If we were, there would be 80 scenarios. But yeah.
1 and 2 are super close. There's 7 5th graders and 8 8th graders. How many unique 5th grade and 8th grade pairs can be formed? It's like the buddy system. Okay, so yes, the correct answer is 56 here. So like you would multiply the 7 fifth graders for one half of the pair times 8 possible eighth graders for the other half of the pair. And then 7 times 8 is 56. Okay, Liv has 3 rings, 1 necklace, and 4 pairs of earrings. How many combinations can she have? Ooh, so you can wear different earrings, I guess. Yeah. So you can mix and match your earrings. All right, yeah, so the wording is a bit tricky here. But by like that, those 4 pairs of earrings. So you have 2 ears, 4 pairs of earrings is 8 earrings. So then you get 30 times 1 times 8 for 24. Ooh, okay, now for some trivia. 5 of you picked true, but we went over this like, I don't know, 15 minutes ago. So we're not going to be having homework for this course, but sometimes we might just post like a few optional problems for you guys to do if you want extra practice. Cough, cough, it might help you cough, cough. Okay, and then also if you want, if you like do it and then you want, like you have questions about some of those problems, feel free to email us. Or if you just have problems about like, questions about like how to solve difficult problems in math cons in general, you can email us as well. Ooh, what time does class start and end? Imagine if one of the options was 7 a.m. to 8 p.m. But yes, you guys have it correct. And all of you guys showed up on time. So of course you all know. You want to wake up at 7 a.m. on Sunday? Well, I'll tell you something, we do not. Okay, yeah, so class starts at 7, ends at 8, and it'll be continuing like that for a long time. Okay, congratulations. 3rd place Sanvi, 2nd place Aryan, and 1st place getting 8 out of 8 questions correct, Shlok. And congrats to our runners up as well. Thank you to everyone else for participating too. Okay, Shani, is there something else like we want to go over since it's towards the end?
Yeah, I don't think so. However, if you all have any questions for us right now, like about math camps, like I don't know, the type of questions, or like I don't know, something about that, or if you have questions about the course, you can ask. And yeah, we don't answer questions like what is math? Like I mean specific questions that we could answer.
Is Mathema every Sunday? Yes.
Yeah,
It's gonna be every Sunday for the rest of your lives.
right. You all will be like 98 and still coming to our class. So yeah, we were gonna have 1.5 hour classes, but because of like time troubles with the volunteers, we could only do 1 hour classes. So yeah, sorry about that.
But you guys are all 8th graders, so we got to shout out our course and shout out that you guys can become teachers. You can apply to become teachers and go through our rigorous selection process. And then maybe we can do 1 hour and 30-minute classes next year. We'll see.
Yeah. So after this class, you can apply to be part of Mathema, like before the summer, and you might even become part of us and even like teach kids who you know, which would be weird, but also cool for you.
Yes. You get all that clout, you know?
Right. and then like it also looks good on your application. But also it's a like
Shiny.
it's a time commitment though. So like don't just do it if you want it on your application. But it's nice to think about.
How to become a human. I wouldn't know. I am a robot. High school.
Yeah, you don't get high school credit for our class, unfortunately. Because we're not like, you know, a school. You know,
But you'll be better at math than everyone else not taking
Right.
this course.
it could help you on the placement test for high school math. And you could even like go up or something. Which would
That's
be
a
cool.
fantastic analogy.
Okay, I'm just gonna end the recording.